represent unique object. If you can prove that unique, then you are owning it. Right? You are owning it. Now the screenshot of the painting doesn't matter anymore. You are the only one who got that NFT, and that is your ownership. Okay, so with that, you can see here a lot of now artwork is using the NFT just to prove that ownership. For example, on the right hand side, you can see that the artwork sells for 69 million. That's pretty awesome again in 2021. See, that is just like a collection of, I don't know how many days, 5,000 days of work of the certain the author of that. Okay, and here is a chart of that. The thing that is a collectible NFTs are more popular. Okay, games, of course, metaverse, art, utility, and the other collectibles. And I put on the right hand side just one very first tweet. Right? You know that Jack Dorsey, the former CEO of Twitter, and sold this very first tweet as an NFT for over nearly $3 million. But this you can see that the very first tweet in 2006. Okay, so just like you can always take a screenshot of this, right? But he's the only one that can prove that he got ownership of this. So he sold that for nearly $3 million. Okay. Or this one, maybe I skip with someone with interested in distributed enterprise. Basically now, today, especially after the COVID, a lot of the company, a lot of enterprise choose to save costs by going digital a lot. But they always go for like the virtual first, remote first, before doing the in-person approach. So that also opens a lot of the potential, the way that you operate, the way that you do business as well.
Up cả cái này
That allowed.
Up vào đâu được cả cái này?
Okay. Privacy, security, as I said, is important, right? You want the data now available a lot, yes. You want to share the data widely, but at the same time, you want it to be secure. You want to have privacy. There is always dilemma like that. So how are we going to address that problem? So that is another trend that all of us can look into, right? Like you got the privacy enhancing computation, the PEC, or you got cyber secure mesh. Some of you may already chosen that research area. So take away that technology. I want just to summarize that the technology nowadays, the trend is that going digital or going virtual is a trend. Right? And digital goods now, creators are huge. You can be the creator. You can be the digital content creator. You can create your own digital assets. You can sell avatar. You can sell anything you want. If you are into games, for example, you can even create the avatars yourself and you sell them, right? So we got now the technology platform for everyone to be independently and creating the digital assets. Okay, so you need to embrace the digital age or be left behind. So that is something to take away from this. But at the same time, we are from technology and engineering point of view background. So we need to make sure that we have to provide engineering just data protection. That's also important. Sometimes that is a little bit left behind in Vietnam in terms of the privacy, in terms of protection, so on. And so I want just to raise that again. Okay, so introduction to the business tree is the main part of the lecture today. So let's just enough time to explain everything. But let's just go for the concept and application. I want to say straight away that business tree is still very immature. A lot of them are still at the concept stage. The full implementation or demonstration is still ongoing. A number of companies, a number of firms throughout the world is trying to do that. But this is the technology, emerging one, not just the industry, the government as well. Take a serious look at this, and has been taking off for the last few years. Increasing of interest exponentially. Okay, so can I just put a few words here for important people, right? Like IoT, sorry, Sky Matthew is a CPO of IBM IoT. He stated very clear that this twin is really the hot new emerging technology in Spain. It's a real thing. It's not just digital, it's not just virtual. It's a real thing. The thing that has to be developed. But at the same time, as mentioned, that because it's still very virtual, people keep debating what exactly it is. If you ask 3 people about what this twin is, you get 5 different answers. Okay, so which means that it's not really firmly defined at the moment. It depending on what you want for the digital twin, what the use cases you are working on. Okay, for example, here I put some quotes, some definition. Okay, so like from Deloitte or from General Electric or from IBM. So Deloitte is more of a consultancy firm in this case. They also have a keen interest in this. They define their own version of digital twin for basically like the evolving digital profile of the historical or current behavior of a physical object or process. So the key idea is that they look into the business performance. It has to be optimized. That's about it. Okay. At the end of the day, any technology firm or enterprise or businesses, they look into that. What are the performance? Can we optimize that? So that is the idea of this thing. To them, it's just simple like that. Okay. For General Electric, the same thing. It's also the digital representation, but you can see that they use the keyword dynamic. The dynamic make it different from the traditional simulation, right? In the past, if you cannot do anything in real world, you try to replicate that in digital world by using what we call simulator or simulation. And we'll go a little bit further by calling that emulator. But digital twin is the next version of that, going fully virtual. But the key word is the dynamic. We'll come back to that point later. Okay, and IBM a little bit longer. They keep going for that. Okay, it's not just a simple system anymore. It's a complex digital model. So the digital need to be intelligent enough to handle a very complex system. Sometimes, if we talk about this thing, we talk about system of the system, right? Okay, for example, within a smart factory, you've got many different processes. Some processes are about just manufacturing, some about safety, some about the performance. So all together, in itself, they can have their own digital twin. So the definition of IBM here that this need to be able to be an ecosystem of connected digital twins. So it becomes back again to the point of system of the system. You can have digital twin just focus on the safety in a smart factory. You got the digital twin just focus on how we produce the product in the optimal way. Or you got the digital twin just care about any anomaly you can detect along the way. Also, this is just for the maintenance purpose. So altogether, we got the whole ecosystem of digital twin, and that come back together to the point of system of the system. So more complex. Right. So a lot of us has been asking, as mentioned about the word debate. Okay, debating about digital twin. Some just mentioned, okay, again, it's just a simulation, right? Just simulation. Or others say that maybe simulation, but a little bit more intelligent in the way that you integrate machine learning and AI into that. Okay, so that's fine. At least we start from somewhere. The debate can keep going. But as I said, that the definition and the development of this twin is just evolving, and it's still at early stage. So we, even ourselves, we contribute to the knowledge and to the database of knowledge for the digital technology. Why digital twin? I think the key idea at the beginning I want to say that, okay, it comes from manufacturing, actually, from manufacturing. You know that they want to improve the productivity and also the PLM, right? The product life cycle management. They want to manage the whole life cycle of product from the moment that they put the order in, and then the whole manufacturing system working on and then produce the product until that they are delivered to the market, delivered to the customer. So that the whole process, the whole life cycle of the product like that. how we can improve the performance of that in a better way, not manually managed. So the PLM process has been the key motivation to create the concept of digital twin. But then it could keep going on, that moving to asset management and then maintenance and health issue. If you can predict the uncertainty in advance, or you give early warnings of the breakdown of the system, that would be better, right? And then people from the healthcare sector, the doctor said, okay, by the way, can you predict that the cardiac problem of such a patient? If you can do that, that can prevent a lot of failures cases, right? If you can, a lot of people, even the professional footballers, you can see that in some of the very famous cases in the World Cup, when the dad, I think the player from Denmark, collapsed on the pitch. Collapsed on the pitch. That the top professional footballer can collapse, and that can happen to anyone. Can we view a digital twin of every single person? And then predict that what will happen if you don't do it this way. So that again is the motivation to create the digital twin. And so I come back to the point that digital twin is this for anything. The answer is yes, simply yes. We are not going to do that to say that we can create everything, but the concept can be applied for anything. We say about asset management. So in the UK, many organizations, they want to create a digital version of their buildings and or their facility. So why? Because they want to have more efficient operation of that, save energy, and also better interaction with the human being, with their staff or student, for example. So all that can fit very well with the concept of digital twin. You reduce the risk of accident, and another key word is the preventive maintenance. You don't wait for the system to break down before you then repair it, but that will be costly. You can predict in advance, okay? And you say that if we're not going to do maintenance now, it will collapse in 3 months' time, for example. It will break down 3 months' time, then that capability of predicting remaining useful life cycle of the system, because that is predictive maintenance. And many other things, but I need to skip because otherwise I may not have enough time. Okay, so I think that everyone remember the Apollo 13, right? The case of that the Apollo 13 on the way back to the Earth. That huge problem that. So to rescue that spaceship, get back to Earth safely, the NASA center on Earth here have to replicate like another spaceship in real-time conditions. Simulate all the conditions exactly the same, but with the inputs from the real spaceship who was having problem up there, right? So they replicate it in real-time, rushing because they don't know not so much time to do. And that is exactly the idea of this real-time. Very important. You have to be able to handle the problem in on real time. At the same time, you receive the data, information from the real system, from the real object, constantly. And then the simulator on Earth trying to make the optimal solution. Find what is the best way to get the spaceship back to Earth safely. So that you can see that looking back from 1970s, that incident in 1970, right? And already you see that is the concept of it. Since then, NASA is always advanced in this technology. They always have the digital of their own spaceship, very advanced technology. They are able to build and or do things on real time is also available. Okay? And then you can see that many other one introduced by for example the neural ones, voiced by Viễn in his book, or Michael Briggs. He's now he's I think he's the CEO or the director of the London Twin Institute in Florida. He also presented very first concept of digital twin, but he called that a virtual space for PLM, product line management. In 2010, so officially John Vickers from NASA introduced the term digital twin, And you can see that from the last period, from like 2017, the interest in this field has been picking up. It's been picking up a lot, as I said, increasing exponentially. Okay, from the research article to the Google search. Right, so what is the key concept is in? Because as I said, that many people say that just a simulation of the real system. We have done that for ages. What's the difference? The key thing here that the two systems, the physical and digital, exist side by side on real-time basis. Real-time is very important. Okay, but I won't come back to the real-time basis because a lot of people say that it doesn't have to be real-time. The definition of real-time is very different as well. Okay, and the second thing that need to be evolving together. The first person of PTIT may not exactly replicating the real system, but eventually it needs to keep evolving two systems, to improve each other. Okay, so to be able to do that, there should be a way of communicating in two ways. Information is shared in two ways. No way. If you give me the data from the real system, I will provide you what's the optimal system to be made in there. And then I got the data back. The loop is going on like that. Eventually, you come to the optimal state of operation, right? Okay. The second thing, you have to bring intelligence. Okay. Intelligence means that you be smart. You need to predict things. Okay. In the real system, you may not be able to try out different things, but in the virtual system, in the digital twin system, of course, you can test. If you can have the vision of a car, you cannot crash the real car, but you can crash the virtual car, right? The digital car. Okay. And the last thing that the difference with the changes in the simulation system, that one you develop a simulation, you run it, you got the result, nobody you stop. You happy with that, no? But the digital is one that lasts for the whole life cycle of the physical system. It's not just finished and then that's it. It has to be lasting the whole life cycle and keep improving. Right, so I think maybe I just keep this gift, but now central, we have a very comprehensive definition of institute. As I said at this stage, just to put forward the official definition of what is the discipline is also important. I think I just summarize again a few points mentioned that the connection between the physical and digital one need to be two-way, right? Always. And the rate of synchronization, the fidelity, and the enabling technology, it needs to be enhanced on the new cases because you cannot have like definition of one for all. Sometimes that is difficult to fit everyone, fit all the use cases together. And at the end of the day, from the enterprise of business point of view, organizing point of view, you need to make sure that is the focus on the business value. You need to add that with the organization, otherwise what I'm doing is this thing for. Okay? So, okay, we got a couple of papers on the different marketing. You have now that we got more information with that. You see, if you're interested in doing for the 5G city network, that's the one right hand side. On the left hand side, more comprehensive survey on this thing, everything, and then challenges, future, prospects, and so on. Okay, so if you look at the digital market, you see that the market in 2020 is $3.2 billion. And but the prediction by 2026, 48 billion. So you can see that the rate of increasing is really, really sharp that way. Okay? Yeah, there's the same trend here. They put in the more graphic. You can see that I just wanted to emphasize again that it just exponential rate of increasing. And maybe for just to get about the numbers in there, I can see that some of the areas that digital market had, automotive, transportation, energy, utilities, open commercial, aerospace, oil and gas, healthcare, agriculture, and even telecommunication. this is not to scare you, but it's just to put forward that so many companies have been holding the development of this thing. Whether that in manufacturing, you see the industry consulting, or develop 3D engine, or glass services for the design. The number of them there. Okay. You have come, you look into what exactly is that, what company you do what. Okay, so what can you base? Because when you build greater lead technology, people will ask what is sport. What is the potential of basis you can have. So I think I can go very quickly with this, but I want to spend a little bit of time to teach you about the real work you have done at our center. But we're going to keep going on forever about this. I can talk about what is background or what is the development technology behind that. But I want you to know that what's the new cases, okay? What is the potential new cases. Okay, by waiting for the computer to respond to this, the two cases I mentioned that we can create that, we have the concept, we have some fundamental technology or enabling ability behind this, but then we need to see what the potential application is. So that's why we consider the two cases. The very first one, I'm going to tell the story of this. We have a project funded by the British Council, working on the business stream for what we call structural health monitoring. What does that mean? That means that you can use the digital technology to monitor any important infrastructure, including like the airport, the transportation facility, or the bridges. See, now project we focus on the bridges in Vietnam. Okay, so that's the reason our team has been like going all over the country. We go to the Bridge, Hanoi Bridge, and here in Children, Cần, many different bridges. We have been going to collect the data to build a business universe of the bridges. And to analyze it, to see if how this new model is accurately representing the real bridges. So, if you remember a couple of years ago, Hanoi Bridge has been closed for repair, right? You can remember that? Because the surface banking has been damaged to the surface that it cannot be in operation anymore. So we have been invited to come to the service. There has been a systematic problem with it. Just keep on again and again and again. So we have been invited to structure, as I said, the bridges, the example from the Hanoi Bridge I mentioned. Environment in Europe, they got the project on digital twin of the Earth. Okay, that's a huge project to tackle climate change, funded by European Horizon. And in telecommunication, in myself, we got an ongoing project. Just a couple of days ago, I was in India for this project. We got with the Institute of Science in Indian Institute of Science in Bangalore. A number of professors there about how we can use digital to develop what we call the hardware before. I chopped that cake into smaller pieces, and everyone can have their piece, right? Everyone can have a smaller one. So by replacing the hardware by the software, that's what. Then suddenly you can have like in many cases in the RAM system. Yeah, the small company doesn't have to do the whole thing. You can do only one component in there. The problem is that when you have so many guys to join the game, to join the creative process, then you have to open standard where they can hold each other, right? You can hold each other. Likewise, access right here between talking to another access point there. So that's why we got the open run to diversify the telecom market.
And this is challenging as well in itself. And we already think that this can help with optimization of the increasing the operation efficiency of the ground network. Still ongoing. I can maybe later on, in a couple of months, I can share a little bit more about this. But at the moment, I think that we still at the level of architecture, what we will add in there, what is the intelligence. If anyone go into more, we will talk about that in later on. Okay, maybe we skip this bit because also he's doing for 5G, not just about that, but about the network emulator, creating traffic. Because getting the real traffic is not easy. I don't think in Vietnam you have that either. All the network providers, they give the data for themselves, and they are not easy to share the data with the normal researcher like us. The same thing in the UK. India is the same. I keep asking them where you can access the real data. So how can you get data? Normally you got a company creates a emulator. For example, I was next to the solution to create exactly the equipment we can generate the traffic data. The case of insurance chain, business, and so on. But maybe we just skip this. And can you move to the next slide? Retail supply chain, automotive, as I said, and the environment as well. The destination Earth, the project I mentioned from Europe, they try to tackle the climate change with the business. Okay. These two components, maybe this part, we don't have time to go through all of them. What I mean that the component is that what exactly is there? How we can create the business between? That is the next part. Maybe in another lecture we can have that. But here, today, I'm not too ambitious to go through everything. We may have just have an introduction about the business, the concept itself, the implications. But when we have time, we may go more the approach about the components. So let me skip to the one that I wanted. Okay, so that is the block diagram I mentioned, the development, how we do that, and even the 3D modeling. And the state of play around the world at the moment, evolution of that, but Siemens, GE, ANSYS, there's a system, another leader in the market. Okay, and a little bit about the working group, because you said that do we have any standard for these three at the moment? Right? You may ask them. I have to say that we don't have too many. Because as I said earlier, yes, there is one ongoing standard, and maybe published very soon, is the consumption stage. They are asking for what's the input for this. We are planning to put this standard forward. What is the opinion on this? So at the moment, it's still that stage. So I can go back to the slide. So, no, the next one. In the UK and the USA, you see that they have a working group. In the UK, for example, they formed the National Business Between Program. That the government funded for a number of people from different sectors to sit together on a group, to work to build this group. So one of the meetings, you may see me on the left-hand side that we attended that meeting, we found out that what would be the data exchange framework that we can have with this thing, and many other difficulties that we can face when we try to create this thing, and how we can make this thing connected together, because the isolated, silo business team is not helpful. Okay, and in America, we got the same group, but we call that as a business team consortium, involving a lot more partners from industry. Okay. Right, maybe this is the last bit I want to focus on. Talking about this field without talking about what we have been doing. I've London using this sector, I think something missing here. That's why we need to have this field. Can you go to the next slide? So the project I mentioned is that, okay, at our London Research Center, we have this on the left-hand side here, with the festival facility, because smart festival. In that, so in that factory, it's basically creating or replicating assembly line for mobile phone production. Okay, so we've got 2 islands and 1 automated guided vehicle. We call that a carrying the equipment between the two islands. Maybe the picture later on will show clearly. But the idea you can see here, representing this thing. On the right hand side, this is the version of that. Providing some a lot of the feedback to the actual system. By actual system, more than 40 sensors, IoT sensors. To provide all the data back to the district. And they work together in parallel to make sure that they can do all the things we want, like fault detection, preventive maintenance, and real-time monitoring of the situation there. So that is our project funded by the government. Maybe I play a little bit of this video. Yeah? For some reason, I think that the video not necessarily blocked. Here. This is a video basically that on the top half is the real system, on the bottom half the version of that. So everything created in real time, we monitor everything, every single thing. But once we got the data, what are we going to do with the data? Like I said that the next step is the predictive maintenance, fault detection, and so on. Predict what will happen in the future if you don't do certain things. So the smart grid is still ongoing, but at least now we've replicated this version of the actual smart factory we have. This picture maybe, yes, much better picture. You can see two islands on the right hand side. One island taking care of the back cover mobile phone and insert the circuit in that. And then another island to insert the front cover, assemble the front cover, sealing and apply the vessel. Measure everything, make sure that product, the mobile phone is up to the standard of quality. And the road, you know, is the one on the left-hand side, is the one that conveys the mobile phone between the two islands. And you can see how these two almost exactly replicate what we have there, right? So that's the very first example of the demonstration of how these things concept. Okay? Right, but at our section, we are doing not just about the implementation of this field, we do some fundamental research. And in this example, for example, we create a framework using the industrial IoT for mostly health monitoring. So this is quite fundamental. To implement this idea, we need to work a lot with the people from festival to do this. And they are not very keen either. We need to go to the level that we need to change the behavior of the sensor, increasing or decreasing the power level of the sensor to make sure that we can detect some system. The idea is that, okay, if some component in the system, in the factory, not working well, then the sensor can increase the power or drop the power to a certain level. They keep conveying the message, but at the same time, they deliver the second message saying that, oh, it's not well. You need to check. So you got the red state that we have to stop straight away. The amber state that maybe you need to look into that. If you don't look in 3 months, it will be something bad will happen. So we create that kind of framework in here and using machine learning to detect that message from the sensor. And we got some result, a little more mathematical, but the machine learning I mentioned is just use the autoencoder to detect the behavior of body signal from the sensor. Right side, you can see that the different power level, alpha 1P, alpha 2P, representing different reading status, amber status, and rest status. Very simple about the machine health. Then, okay, we stop that. Let's see if we can play now. How much time do I have left? Look, watch out for the collapse of that bridge, right? In Taiwan, 1990. We don't want to see that. Okay? We don't want to see that what happened like that. That's why the structure of how monitoring is important. We don't wait for until accident like that happen. Unfortunately, around the world, especially in India, there is so many cases of fatal accident like that, or the incident like that, collapse of the bridges. Now, on the right-hand side, anyone recognize what on the right-hand side? That's the Hammersmith Bridges, overlooking the southwest of the Thames River in London. And it's just a few minutes away from my house, my home. And why I take that? Because it has been closed for repair for more than 4 years. With no ending at all. I can see that's still going on forever. because the cost to repair that bridge is so high, equivalent to if you complete a new bridge. But you still cannot easily, basically, people say that is a great historical bridge with a historical value. That we cannot just then destroy that bridge and build a new one. But the cost to repair that is equivalent to complete a new bridge. Basically, for now, only you can walk through that. You cannot go by car or flying anything. And it's still destruction to the rest of it around that area. So what I think that the message that the structural development is very important. But this project is about project financing. We partner with the University of Transport and Communications. The other one on the other side is city. And we work on a number of different projects. We see that come up with over there, we can try to see and collect the data. For example, I mentioned Trong, buổi, that is a successful example. If you want to see more of that, we already appear on the destination program on the one. You can watch that video again. About this project. This is the interface that we try to develop everything on the cloud. But when we look into that, the way we develop this field, you can see, I want to point out, we start from let's see for one. This is like the bridge on the lab. We bought it from Amazon for $250 now. Just get some sense of it, get the concept, see it work. The communication strength, and so on. And then we create maybe more real bridge. Not real, but using real material. And that is just like 4 meters long on the land as well. After that, once we're confident with the concept and everything, then we go to collect all the data of the real bridge, and then we work out from there. So if you need a very complex system straight away, it's not easy to create this zero data. Okay. There are so many lessons we learn from working on this type of project. One of the things that was everything in real time. Because the bridges, we don't need every second. You need to update what's the new status of bridge. Right? Even not every day. But in every bridge, still okay. So, but for self-driving car, for example, you have to create a digital self-driving car. Wow, the synchronization level will be very high. Sometimes we call that fidelity is very high. Because we need mechanisms within every microsecond millisecond. Otherwise, accident will happen. So depending on application cases, that is a real time security. Okay? So we may have to see all this thing, all the lessons when we have more time to share with you. For example, like the lesson number 2, we say that start from the very small, simple thing. And this may apply to the other project you are doing as well. Don't need something too complicated that you cannot validate. Get the idea, the proof of concept first. The simple thing. So from the simple toy bridge we bought from Amazon, do a little bit more real bridge we do in the lab, and then the actual one later on. Okay. And design approach, as I said, a lot more feature than usual. You realize that even the new features in here now, 50% sensor may not be working. So we need to go and collect the data by ourselves a lot more than before. AI is a way at the core of these issues of because it uses a lot of deep learning, architecture, model detection, and for forecasting responses and so on. I'm not necessarily good, successful project. And this project has been funded by people. Next place. Okay, so this is the next example. We have another project working with Egypt from University of Cairo. And this project, you know, in Egypt, of course, you can see that the habitat is huge. But maintaining and replicating the good operation stage is almost a challenging. And this project look into that the technology for that purpose. Okay? And I think another project is about working with the team from Asia, Indonesia. This university is one of the strongest ones in healthcare. we four connected hospitals. Because the whole hospital is four aspects of 2008. Smart agriculture, working in Hamlan University from Vietnam here, and funded by the Council. Basically, we try to increase the automation for monitoring and control of smart agriculture. In this case, we focus on the vertical farming concept, inspiration, motivation, and how. We've got the lockdown example. Lockdown. Secondly, it doesn't matter that the level of the country you are in, good income or low income, you suffer all the same, the shortage of agricultural products. The lockdown just let it go. Even now in the UK, sometimes it is news that we will have tomatoes in the UK, shortage of agricultural products. So this is also included in urban context, how we can increase the supply chain to make it more efficient. Can we use technology to create automation in this in urban context? Now going back to the issue for open plan, then this one, I would love to have any collaboration with any team here from staff member or student working here. If you're interested in see the impact of working on open plan or to see if we can design this new approach for this, happy to discuss with you. This one still on a very early stage. We haven't done any implementation, but we have industrial partner, very strong one, that is HCL from India, and the Rakuten Symphony from the UK, Rakuten actually from Japan, but the team work with it from the UK. And they are all strong in open plan. We've got a business expertise as well, and we've got, of course, we also got background in open plan. So we are confident with this, but also understand that validating this concept is not difficult, especially we don't even have the real data to validate it. Okay, so in that, I think that maybe I just stop my lecture here. But my lecture did summarize again that I'm not going to tell you how to develop this video yet, but what I've just done is that I've introduced you to the new emerging technology area that is tree. What is the concept, right? And what's the potential application of this tree? If you are really interested in that, then the next step we look at how I can develop this tree. What is the step? And some of the use cases, some example of the research project we have been doing at our London Tree Research Center. So hopefully, just an introduction to the new emerging technology, and with some if anyone interested in this, feel free to contact me or have any question. Okay, so thank you everyone. I just stop my lecture here.
Twins technologies. So now it's time for our students to have questions. So please raise your hand and give us your questions about the topics today.
Hello, Professor. I would like to ask what do you think about the relationship between digital twin technology and the artificial intelligence?
Digital twin and which one?
Digital twin technology and artificial intelligence.
Artificial intelligence. As I said, I think one of the lessons I think lesson number 4 in the concept of the structural harmony. AI always as a core of this technology. One of the key things in the concept of this is that you need to bring intelligence to the system, right? You need to be smart. Okay, you want to predict things can happen in the future, you need to be smart in a certain way. How to be smart? Make sense of the data, right? Just come back to the point of this. When you learn about science and engineering, anything you can solve by hands, you You can solve equations by hand. You can solve mathematically. Then you don't need to run the data simulation and thing, right? Simulation just to validate whether our solution. If you can solve the integration by hand, you do that. If you cannot do that, then you use simulation just to like use the numerical method to do. And in reality, nowadays, that sometimes we cannot solve the equation directly by hand. So in other words, we do not have those one solution for solving in a mathematical way. So a lot of the replacement solution is that, okay, numerical method, or use the data, run machine learning algorithm to predict what's the behavior. A lot of people complain that machine learning just like black box. We don't know what's going on inside. It's got the input and then get the output. Whether that the training model is accurate or not, that's another thing. And AI now so advanced. You can see that the number of headlines used nowadays, ChatGPT and all the other things. We have to think that we have to embrace the AI as the core of the digital technology. It's not about the relationship, it's about that AI is an important component of the digital team. Hope that answers the question. Any further questions? Yes, can you bring the microphone? You want to ask a question?
Professor, I have a question for the topic. Is big data an important issues in digital twin technology? Thank you.
Sorry, what's the first bit of the question?
Is big data an important issue in...
Big data?
Yes, big data.
Okay.
Yeah.
No, I think that's a very good question as well. Not just about these things, when we talk about AI or we want to try to model things, a number of times that we say that we do not have enough data to have accurate representation of the actual system. And I give one example just to tell you maybe that can help you with the answer. In the framework, when we try to look at the predictive maintenance, what is predictive maintenance? Predictive maintenance is not actually an example. Very important that you know how much life cycle, useful life cycle of a certain component within the factory still remain. Because we don't want the system to break down. The downtime in the factory is very important. We don't want to have downtime at all. So we need to know in advance how much time left of that component of that system. So we try to develop that framework for we go to maintenance in our factory. But unfortunately, we don't have enough data. All the data we collect is very normal, nothing unusual, perfect condition. How are we to get the data with the different things for our machine learning to learn? So data is important to create a meaningful business model. So I have a ability to big data, but I believe that big data is so important here. If you can collect the business system in a way that you get the data from sensor, you got data from historical modeling method, you got the data from even the human inputs. Because sometimes we don't have the fully automated thing, you have human in the loop as well, in some part of that. So that forms a part of very much multimodal data that is needed for this thing. So big data is very important. I hope that is the answer. But at the same time, as I said, that it's not easy to collect so much data at the moment, from my own experience. And every time we test, we come with different model than this thing. So if you come with an answer like that, if you come with an output like that, you have to say, why is there no consistency here? What's going on? And so one of the methods we learned that we try to collect some of the data from somewhere else, of the similar system. So we imported the data from NASA for their milling machine. There was 60 milling machine data set available in open source. And then try to do some transfer learning back into the class system. But I have to think just to tell you that okay, a lot ongoing to create the exact person of PTIT. It's not easy, and we take that, I believe it's important in that process. Thank you.
For our students' questions. Apparently, we have an enormous question to be discussed. However, due to the time limitation, we have to end the discussion now. So once again, please give applause to our speaker today.
Thank you very much. It's my absolute pleasure to stand in front of you to talk. And some of my old friends as well, if I can see, I'm Ngọc. Okay, so you see that it's great to be here with you. Once again, thank you, and hope to see you soon, sometime in the future.
Yes, thank you very much.